SHM, simple harmonic motion. Like this is the topic common for all the competitive exam, very easy and important topic. First of all, before going to simple harmonic motion, what is SHM? What is SHM? Rather than that part, so what will be now? So oscillation. What do you mean by the word oscillation? Chala important andi, oscillation ki SHM ki difference. Oscillation means what? To and fro motion of a particle is called as what? Oscillation. To and fro ante enti, venakki munduku. To and fro motion of a particle is called oscillation. To and fro motion of a particle, to and fro motion of a particle across a midpoint, is called oscillation. ఏమందాం దాన్ని? Oscillation. To and fro motion of a particle across a midpoint is called as what? Oscillation. వెనక్కి ముందుకి. మరి సింపుల్ హార్మోనిక్ మోషన్ అంటే ఏంటి? SHM, సింపుల్ హార్మోనిక్ మోషన్ అంటే to and fro motion of a particle across a midpoint in regular intervals of time. So there is a lot of difference between oscillation and simple harmonic motion. Oscillation means what? There is no rule to follow the regular intervals of time, but simple harmonic motion means it need to follow certain time period, that is called regular intervals of time. So simple harmonic motion, what it is now? To and fro motion, to and fro motion of a particle, to and fro motion of a particle across a midpoint in regular intervals of time, is called like a simple harmonic motion. In our syllabus the examples given are circular motion. First one is what? Circular motion. Next one is what? Simple pendulum. These are the two examples given in our syllabus. We need to go in detail about the simple pendulum in the chapter. Here we can write the statements, two statements here, like all SHMs are oscillations. All SHMs are oscillations. But all oscillations are not SHMs. జాగ్రత్తగా చూసుకోండి. All oscillations are not SHMs. ఇప్పుడు ఒక్కసారి డిఫరెన్స్ చూద్దాం మనము. ఆసిలేషన్, వాట్ డూ యూ మీన్ బై ద వర్డ్ ఆసిలేషన్? టు అండ్ ఫ్రో మోషన్, వెనక్కి ముందుకి ఒక పార్టికల్ వెళ్తూ ఉంటే దాన్ని ఏమంటాం మనము? ఆసిలేషన్. మన కామన్ లాంగ్వేజ్లో అయితే వైబ్రేషన్ అంటాము. సో SHM అంటే ఏంటి? అగైన్ టు అండ్ ఫ్రో మోషన్ ఆఫ్ ఎ పార్టికల్ అక్రాస్ ఎ మిడ్ పాయింట్ ఇన్ రెగ్యులర్ ఇంటర్వెల్స్ ఆఫ్ టైం. అంటే అదొక సర్టెన్ రెగ్యులర్ టైం పీరియడ్ని ఫాలో అవ్వాలి. దాన్ని ఏమంటాం అప్పుడు మనము? సింపుల్ హార్మోనిక్ మోషన్ అంటాం. కాబట్టి వాట్ వీ కెన్ కన్ఫర్మ్ దట్ ఆల్ సింపుల్ హార్మోనిక్ మోషన్స్ ఆర్ oscillations, but all oscillations are not simple harmonic motions. మన సిలబస్లో two examples are given. What are the examples? Circular motion, and second one is what? Circular motion, and second one is like simple pendulum. These are the two examples given in the syllabus, right? Now let's have a look about the equation. First, general form of equation. మీకు అర్థం అవ్వడం కోసం first I'll start with an example. Look here, this is the simple pendulum, perfect example for SHM. ఈ పాయింట్ ఏమంటాం మనము? మీన్ పొజిషన్. what we call it as mean position. దీన్ని డిస్ప్లేస్మెంట్, ఇట్ ఈస్ ఈక్వల్ టు A. A stands for what? Amplitude. దీన్ని ఏమంటాం మనము? ఎక్స్ట్రీమ్ పొజిషన్. what we call it as what? Extreme position. So ప్లీజ్ లుక్ కేర్ఫుల్లీ, దిస్ ఈస్ ద ఇంపార్టెంట్ క్వశ్చనింగ్ ఏరియా. మన క్వశ్చన్స్ అంతా దీని చుట్టూనే తిరుగుతుంటాయి. మీన్ పొజిషన్, ఎక్స్ట్రీమ్ పొజిషన్. ఆరిజిన్ దగ్గర దాన్ని ఏమన్నాము? మీన్ పొజిషన్. సో అట్ ద మ్యాక్సిమం డిస్ప్లేస్మెంట్ పొజిషన్, దట్ ఈస్ ఈక్వల్ టు వాట్? యాంప్లిట్యూడ్. ఏ స్టాండ్స్ ఫర్ వాట్? యాంప్లిట్యూడ్. దిస్ ఈస్ కాల్డ్ ఎక్స్ట్రీమ్ పొజిషన్. దిస్ ఈస్ ఆల్సో కాల్డ్ యాజ్ వాట్? ఎక్స్ట్రీమ్ పొజిషన్. నా ఐ నీడ్ టు రైట్ జనరల్ ఫార్మ్. చాలా జనరల్ ఫార్మ్స్ ఉంటాయండి మనకి, సైనసాయిడల్, లైక్ స్క్వేర్ ఫార్మ్స్, క్యూబ్ ఫార్మ్స్. బట్ ఇన్ అవర్ సిలబస్ ఫర్ ద ఎగ్జామ్ వీఆర్ హ్యావింగ్ ఓన్లీ సింపుల్ సైనసాయిడల్ ఫార్మ్స్, రైట్? ఇప్పుడు చూడండి, ఇఫ్ ద పార్టికల్ ఈస్ మూవింగ్ ఫ్రమ్ మీన్ పొజిషన్ టు ఎక్స్ట్రీమ్ పొజిషన్, మీన్ పొజిషన్ టు ఎక్స్ట్రీమ్ పొజిషన్, like what is the general equation now? Y is equal to A sin omega t, A sin omega t, or A sin omega t plus phi. Let me explain the terms. Okavela particle is moving from extreme position to mean position. If it is moving from extreme position to mean position, then what is y is equal to now? A cos omega t, A cos omega t, otherwise A cos omega t plus phi, omega t plus phi. The important thing, exam lo language ni batti maripotuntundi mottam manaki. Now look carefully. So if the particle is moving from mean position to extreme, what is the general form? Y is equal to A sin omega t, otherwise A sin omega t plus phi. Eppudu particle is moving from mean position to extreme position. The equation is what? Sin omega t or sin omega t plus phi. If it is moving from like this, extreme position to mean position, then the equation becomes what? Y is equal to A cos omega t, or Y is equal to A cos omega t plus phi. So the most important relation. Now what is the meaning of each and every term? Y is equal to displacement. Y is equal to what? Displacement. Now what? A is what? Amplitude. A is what? Amplitude. Y is the displacement. A is the amplitude. Omega t is called as what? Phase. Omega t is called as what? Phase or angle. Now what is phi called as? Phase difference. That is extra angle. Phase difference, that is extra angle. Now look at the each and every term here. So y is equal to what? A sin omega t, or y is equal to A cos omega t. That depends whether the particle is moving from mean position to extreme position or extreme position to mean position. Here y stands for what? Displacement of the wave. Y stands for what? Displacement of the wave. A stands for what? Amplitude. A stands for what? Amplitude. Omega t stands for what? Phase. Phase means what? Angle. Now phi stands for what? Phase difference. Phase difference, that is extra angle. Now here omega. Omega is what? Angular frequency or velocity. Angular frequency or velocity. Now what is the formula for omega? Omega is equal to 2 pi n, or that is equal to 2 pi by t. Omega is equal to what? 2 pi n, that is equal to 2 pi by t. Here n stands for what? Frequency. N stands for what? Frequency. T stands for what? Time period. T stands for what? Time period. N is the frequency, T is the time period. We know what is time period. Time taken to complete one oscillation. One oscillation. Now we will discuss a little bit in detail about these things. Look carefully. What is an oscillation once again? To and fro motion. So it's called as simply oscillation. To and fro motion in regular intervals of time is called as what? Simple harmonic motion. Is called simple harmonic motion. Right? Now what are the examples given for the simple harmonic motion? Like circular motion, simple pendulum. But in our syllabus we revolve around only simple pendulum mostly. This point is called as what? Mean position. This is called mean position. This is called as what? Extreme position. Mean to extreme, the distance is called as what? Amplitude. Called as what? Amplitude. The important question difference here is that when the particle, examiner ఏమి మెన్షన్ చేయకపోతే issue లేదు. Consider it as moving from mean position to extreme position. So if it is moving from mean position to extreme position, what is the formula? Y is equal to A sin omega t, or A sin omega t plus phi. Extra phase difference ఉన్నప్పుడు, like అదే extreme to mean వెళ్తున్నప్పుడు y is equal to A cos omega t, otherwise A cos omega t plus phi. So this about the description about the simple pendulum general equation. Now let's go what is mean by distance, displacement. Here we'll consider the same example. We'll have a look now. Now this is called as what? Amplitude. Amplitude. This is called amplitude again. Mean position, extreme position. Time period. What do you mean by the word time period? The time taken to complete one oscillation. The time taken to complete one oscillation. To complete one oscillation is called as what? Time period. So one time period where the particle moves from, look very carefully here. This is the origin. It goes first here to here. So in one time period, distance covered One time period means, everybody look carefully, from mean to extreme, from extreme to mean, again from this mean to extreme, again from this to mean. This is called as what? One time period. To move from, so here to extreme, extreme to here, and from here to this extreme position and this mean position. Total twice the journey is called as what? One time period. One time period. So distance covered will be A plus A plus A plus A. Followed everybody? Most important question. Distance covered in one time period is what? 4A. Similarly, sometimes they will be asking, what is the displacement covered? What is the displacement covered? It will be surely 0. Why? Because at the end of one oscillation or one time period, again it is at the mean position. Again it is at the mean position. So there is no change in position. So the displacement is 0. You need to appreciate carefully. So from this I can write, please remember everybody, the most important questioning area I will explain you. Like first of all, the time from here to here is called as what? T by 4. Why? Because entire one time period is 4 times. Now here to here, mean to extreme, the time is what? T by 4. So remember, this is exact mid position, A by 2. Here it will be T by 12. Here it will be T by 6. T by 12, T by 6, you need to remember in this way. Equal time will not take. From 0 to A by 2, the time is what? T by 12. From A by 2 extreme position, it is origin O, it is extreme position A. 0 to A by 2, T by 12. A by 2 to A, the time period is what? T by 6. From here to here, mean to extreme position, the time period is what? T by 4. The time period is what? T by 4. Okay, this is called as what? SHM, simple harmonic motion. Example is simple pendulum. Okay, one time period. What is the distance covered? 4A. Displacement covered will be 0. This plays a key role in all the competitive exams. We will go while the discussion of the time period. Now we will see what is the general equations for the SHM. General equations for the SHM. What is the displacement equation? Y is equal to A sin omega t. Y is equal to A sin omega t. So let me assume the journey starting from mean position only. What is the general equation? Y is equal to A sin omega t. Now velocity is equal to dy by dt. Velocity is equal to what? Dy by dt. So d by dt into A sin omega t. A sin omega t. Now it becomes A omega cos omega t also. But you are no way concerned about this thing. Velocity is equal to omega into under root A square minus y square. What is the formula for velocity? V is equal to omega into under root A square minus y square. Similarly, acceleration is equal to dv by dt. Acceleration is equal to like a minus omega square y. Minus omega square y. Here condition is acceleration is directly proportional to minus phi. If any SHM should satisfy SHM condition, what is the condition for SHM? They will be asking. Acceleration is directly proportional to minus phi, not y. A is directly proportional to minus phi. From this we can write a statement. If any equation satisfies this condition, then only it is said to be what? SHM. A is directly proportional to minus y. Acceleration and displacement are always in opposite direction. Acceleration and displacement are always in opposite direction. Are always in opposite direction. What are the opposite directions? Acceleration and displacement. A is directly proportional to minus y. Now look carefully. What is the equation? Y is equal to A sin omega t. What is the basic equation? Y is equal to A sin omega t. And what is the formula for velocity? V is equal to omega into under root A square minus y square. What is the formula for acceleration? A is equal to minus omega square y. A is equal to what? Minus omega square y. So from this, what is the condition for SHM? Acceleration and displacement must be always in opposite direction. Means phase difference must be 180 degree. Phase difference between them must be what? 180 degree. Most important question. So acceleration and displacement must be always in opposite direction. Then only it is said to be what? SHM. That is simple harmonic motion. Clear everyone? Now we will go the next part. Example is what? Simple pendulum. Next is what? Simple pendulum. As I told you just now, this is the mean position. Mean position. This is what? Extreme position. This is what? Extreme position. Mean position, extreme position. Look carefully now. Mean position, displacement is what? 0. Journey is not yet started. The object is still at the mean position. So displacement is what? 0. Here displacement is what? Maximum. Do you know what is maximum displacement is called as what? Amplitude. Maximum displacement is called as what? Amplitude. Look carefully. At the mean position, displacement is what? 0. At the extreme position, displacement will be maximum. What is maximum displacement called as? Amplitude of the wave. Now here velocity is maximum. Velocity is what? Maximum. Here velocity is minimum or 0. Velocity is what? Minimum or 0. Here acceleration is minimum or 0. Here acceleration will be maximum. These are the important statement questions. At mean position, displacement is 0. Velocity will be maximum. Acceleration will be minimum or 0. Acceleration will be minimum or 0. Extreme position, displacement is what? Maximum. Cover the particle. Velocity will be what? Minimum or 0. Acceleration will be maximum. From this we can come to a conclusion that velocity will be maximum at the mean position, acceleration will be maximum at the extreme position. So that I can tell that phase difference between velocity and acceleration is what? Pi by 2, that is 90 degree. One more statement question. The phase difference between velocity and acceleration will be pi by 2. Because both are opposite, but 90 degree. The phase will be what here? 90 degree. Now look carefully here. When velocity is maximum, kinetic energy will be maximum. Potential energy will be minimum or 0. Here velocity is minimum or 0. So kinetic energy will be 0 or minimum. Potential energy will be maximum. Potential energy will be what? Maximum. Okay. This is about the mean position and extreme position relations, mean and the extreme position. Look very carefully here once again. At mean position, this is the important questioning area for not only ECET, all the competitive exams, the most important part. So at mean position, what are the parameters? Displacement is 0, velocity is maximum, acceleration is minimum or 0, kinetic energy will be maximum, potential energy will be minimum or 0. At extreme position, what are the parameters? Displacement is maximum, velocity is minimum or 0, acceleration will be maximum, kinetic energy will be 0 or minimum, potential energy will be maximum. Potential energy will be what? Maximum. So the difference between mean position and the extreme position. And here this simple pendulum is a classical example for law of conservation of energy. Total energy always remains same, whether it might be at mean position or extreme position. So I am writing one more statement. Simple pendulum is a classical example of law of conservation of energy. Law of conservation of energy. So is it clear everyone? This is about the simple pendulum, mean and extreme position conditions. Now we will see what are the formulas here once again. Now, just now I told you displacement formula is what? A sin omega t. When it is from mean position to extreme. Extreme to mean, it will be y is equal to a cos, like omega t. Velocity is given as what? Omega into root of a square minus y square. Now, at mean position, just now I told you what? Velocity will be maximum. Displacement will be 0. Just now I told you at mean position, velocity will be maximum, displacement will be 0. Omega into a square minus 0 square. A square minus 0 square. So that is equal to omega into root of a square. V max, this formula is given by what? A omega. V max is equal to what? A omega. So right, normal, what is the formula for velocity of an SHM? Omega into root of a square minus y square. What is the formula for maximum velocity of the particle? A omega. In the question you need to appreciate very carefully whether they are asking velocity or maximum velocity. What is the formula for maximum velocity now? A omega. Similarly, acceleration. What is the formula for acceleration? I told you minus omega square y. At extreme position, what I told you, acceleration will be maximum. Displacement will be equal to what? Y is equal to a. So a is equal to minus omega square a. This is called a max, maximum acceleration. Now look very carefully. Formula for the velocity of the particle is what? V is equal to omega into under root a square minus y square. Maximum velocity formula is what? A omega. Acceleration formula is what? Minus omega square y. Maximum acceleration formula is what? Minus omega square a. So this is the primary difference between velocity, acceleration. Ee confusion tote chaala mandi students question mistake చేస్తూ ఉంటారు. You should never get into the mistake now. So this is the possible things. Now force acting on the particle. What is the next part? Force acting on the particle. So F is equal to ma. F is equal to what? Ma. Mass into acceleration. F is equal to mass into acceleration. Minus indicates only direction. F is equal to m omega square y. Maximum force will be equal to what? Maximum force will be equal to m omega square a. So these are the regular part of the questions. Direct formula based chapter. ekkada manam ibbandi pettadi part. So very simple thing. So this is about the general equation of an SHM. The perfect examples for SHM given in our syllabus is what? Circular motion, simple pendulum. Circular motion and the simple pendulum. Right? Now, so this is the part. Now, just now I discussed that at mean position, what will be maximum? At mean position, kinetic energy will be maximum. Right? At extreme position, kinetic energy will be minimum, potential energy will be maximum. At mean position, kinetic energy maximum, potential energy minimum. Ante when you are going from mean to extreme, kinetic energy will be converted to potential energy. Kinetic energy will be converted to what energy? Potential energy. Everybody look carefully. One more relation. At mean position, what will be maximum? Kinetic energy will be maximum. Potential energy will be minimum. At mean position, kinetic energy will be maximum. Potential energy will be minimum. At extreme position, kinetic energy will be minimum. Potential energy will be maximum. When you are moving from mean to extreme, kinetic energy will be converted to potential energy. As of just now I told you, it is a perfect example for what? Law of conservation of energy. Now let's see, what is the formulas for the kinetic energy and the potential energy, total energy. Kinetic energy basic formula is what? Half mv square. Here v just now I told you omega into under root a square minus y square. Now kinetic energy is equal to half m omega square into a square minus y square. Kinetic energy is equal to what? Half m omega square into a square minus y square. Now kinetic energy, now potential energy. Potential energy is equal to half m omega square y square. Half m omega square y square. Now from this total energy is equal to potential energy plus kinetic energy. Half m omega square y square plus half m omega square into a square minus y square. Summary of the story is half m omega square a square, total energy. So once again have a look very carefully. At mean position, kinetic energy will be maximum, potential energy will be minimum. At extreme position it will be reverse. Kinetic energy will be minimum, potential energy will be maximum. The expression for the kinetic energy of an SHM is what? Kinetic energy is equal to half m omega square into a square minus y square. Half m omega square into a square minus y square. Then total energy is what? Potential energy is what? Sorry, half m omega square y square. Then formula for total energy is what? Half m omega square a square. So these are the various relations in the first part of the chapter, that is simple harmonic motion. Simple harmonic motion. Okay. Now let's summarize all the formulas at a single place once. Everybody look very carefully. Displacement y is equal to a sin omega t. Right? Mean to extreme. When it is moved to extreme. Right? Now y is equal to a cos omega t. It is from where to where? Extreme to extreme to mean. Okay. Velocity is equal to omega into root of a square minus y square. Maximum velocity is equal to a omega. Maximum velocity is equal to acceleration is equal to minus omega square y. Maximum acceleration is equal to minus omega square a. Minus omega square a. Now force is equal to m omega square y. Maximum force is equal to m omega square a. M omega square a. Here minus indicates only direction. As if I told you now, acceleration and displacement will be always, phase difference will be how much? 180 degree, and simply acceleration and velocity will be how much? 90 degree. Similarly, kinetic energy formula half m omega square into a square minus y square, and potential energy formula half m omega square and y square, and total energy formula half m omega square a square, half m omega square a square. These are the various expressions: kinetic energy, potential energy, total energy, acceleration and displacement 180 degree, acceleration and velocity 90 degree. Expression for kinetic energy, potential energy, total energy, velocity, acceleration, force. So phase difference between acceleration and displacement 180 degree, acceleration and velocity 90 degree. 90 degree. These are the regular formulas that will be asked in the exam. Okay, and one more important area, as if I told you, now I will prove this also. Time taken to move from 0 to a by 2. It will total time period from 0 to a is what? A, t by 4. Here it will be t by 12. Here it will be t by 6. Now let's prove this part also. Right? Now this is about the general form of the SHM part. Okay? Now sometimes when the examiner wants to go like graph representation, how the graph representation will be there? Graph representation, look very carefully. Graph representation, variation of potential energy. Potential energy will be maximum at extreme position, minimum 0 at mean position. So this will be the graphical representation of what? Potential energy, variation of potential energy. Similarly, variation of kinetic energy, variation of kinetic energy. Kinetic energy will be maximum at the mean position and minimum at the extreme position. This will be the variation of kinetic energy. Nowadays trending questions, these two are variation of potential energy, variation of kinetic energy. Variation of potential energy, variation of kinetic energy. Why? Because potential energy will be maximum at extreme position, minimum at mean position. Similarly, kinetic energy will be maximum at mean position, minimum at the extreme position. These are the two graph representations about the variation of potential energy and variation of kinetic energy. Sometimes some examiners will show the two graphs in a single thing like this. They will ask, this is the variation of what? Kinetic energy. This is the variation of what? Potential energy. Sometimes representation may be in this way also. This is about the graph representation. Now if the phase difference is, this is the trending question, one more thing. If phase difference is 0 degree, the graph will be a straight line. The graph will be a straight line. If the phase difference is 180 degree, straight line in opposite direction. Straight line in opposite direction. Straight line in opposite direction. Otherwise anti-parallel. Anti-parallel. Next, if it is 90 degree, it will be circle. This is the regular question nowadays. If the phase difference is 90 degree, what is the shape of the graph or path followed will be circle. Other than these angles, theta, the graph will be what? Parabola. The graph will be parabola. If the phase difference is 0 degree, the graph will be a straight line. If the phase difference is 180 degree, graph will be a straight line in opposite direction. If the phase difference is 90 degree, the graph will be circle. Graph will be what? Circle. If the phase difference is other than these things, it may be other angles like 30 degree, 45 degree, 60 degree. So the graph will be what now? Parabola. This is about the graph representation related to simple harmonic motion. Right? Now, simple pendulum. So we'll go for one more class on this, but now simple pendulum, right? Now time taken from 0 to a by a, amplitude maximum displacement is what? T by 4. Calculate the time to travel from mean position to half of its amplitude. Mean position to half of its amplitude. అందరూ ఒక 2 minutes జాగ్రత్తగా చూసుకోండి. This is the important questioning area. When it is moving from mean position to extreme position, as I told you just now, the equation is what? Y is equal to a sin omega t. Y ఏమంటున్నాం మనము? Y is equal to a by 2. ఎందుకు సార్? We are telling it is from mean position to half of its amplitude. Mean position to what? Half of its amplitude. Y is equal to what? A by 2. A by 2 is equal to a into sin omega t. A gets cancelled. Sin omega t is equal to 1 by 2. Sin theta eప్పుడు 1 by 2? That is what? 30 degree. What it is now? 30 degree. Omega t is equal to pi by 6. Omega t is equal to what now? Pi by 6. Omega is equal to 2 pi by t into small t is equal to pi by 6. Pi gets cancelled. Now small t is equal to capital T by 12. Small t is equal to what? Capital T by 12. So that is why I told you from 0 to half the amplitude it will be T by 12. Obviously from here to here it will be what? T by 6. T by 12 plus T by 6 will be equal to what? T by 4. Right? This is one of the important question. ఇలాంటి questions వచ్చినప్పుడు ఇట్లా చేసుకోవాలి. Sometimes one more important model about the energies. Look carefully. ఇప్పుడు at what displacement from mean position both potential energy and kinetic energy are equal. Both potential energy and kinetic energy are equal. The question will be like this. రకరకాలుగా అడుగుతారు. At what displacement from mean position both potential energy and kinetic energy are equal. Now see here, potential energy is equal to kinetic energy. I am telling the equation as what? Only hint given in the question is what? Potential energy is equal to kinetic energy. What is the formula for the potential energy? Half m omega square into y square. That is equal to half m omega square into a square minus y square. Can I write like this? Because I am telling in the hint potential energy is equal to kinetic energy. Half m omega square cancels on both sides. Y square is equal to a square minus y square. Y square plus y square is equal to a square. 2y square is equal to a square. Now y is equal to y square is equal to a square by 2. Y is equal to a by root 2. So at what displacement from the mean position? That will be equally potential and equally kinetic energy. Y is equal to what? A by root 2. Y is equal to what? A by root 2. At this position, both potential energy and kinetic energy will be equal. At what position? Y is equal to A by root 2. Got the clarity? Now, one more question. Find the ratio of potential energy and kinetic energy at y is equal to a by 2. Y is equal to a by 2. At a displacement is equal to what? Half the amplitude. At the displacement is equal to what? Half the amplitude. Find the ratio of potential energy and kinetic energy at y is equal to what? A by 2. Once again, similar formula. Potential energy by kinetic energy. Potential energy is half m omega square y square. Kinetic energy is equal to half m omega square into a square minus y square. Half m omega square gets cancelled. Y is equal to what? A by 2. So a by 2 whole square by a square minus a by 2 whole square. This can be written as a square by 4 by a square minus a square by 4. This can be written as a square by 3a square by 4. So this should be now 1:3. Ratio of potential energy and kinetic energy at half the amplitude is how much? 1:3. Like this the questions will be there, mostly based on the potential energy concept and the kinetic energy concept. Okay, this is about the general form of the equation, simple pendulum example, and also time periods. Okosari initial phase adugutadu. So now let's have a look here. Is this clear now? Potential energy and kinetic energy are equal. At what displacement? Y is equal to A by root 2. If Y is equal to A by 2, what is the ratio of potential energy and kinetic energy? 1:3. Sometimes they will be asking potential energy to total energy also. 1/4. Means from this I can write, so at half of the amplitude, at Y is equal to half of the amplitude, I can write potential energy is 25%, kinetic energy is equal to 75%. Like this also the questions will be framed. So at half of the amplitude, potential energy will be 25%, kinetic energy will be equal to what? 75%. Right? Next, one more question based on the velocity and acceleration. At what displacement from mean position? At what displacement from mean position, velocity and acceleration will have same magnitude, ఒకటే magnitude ఉండేది ఎప్పుడు? At what displacement from the mean position? They are telling that velocity should be equal to what? Acceleration. Velocity should be equal to acceleration. Velocity ఏంటి? omega into under root a square minus y square. ఇదేంటి? omega square into y. omega square into y. We can go in this way also. Now squaring on both sides. Otherwise no issue. Omega square gets cancelled. It will be cancelled. Now it will be squaring on both sides. A square minus y square is equal to omega square and y square. Omega square y square. Now omega square is equal to a square minus y square by y square. Okay. Now this also can be written as omega square is equal to a square by y square minus 1. Now a square by y square is equal to omega square plus 1. Now they are asking displacement. Y square is equal to a square by omega square plus 1. Y is equal to under root a square by omega square plus 1. ఇది వెరీ టఫ్గా పేపర్ ఇచ్చినప్పుడు ఇలాంటి మోడల్ డిస్ప్లేస్మెంట్ వెలాసిటీకి యాక్సిలరేషన్ కూడా అడుగుతారు. సో దీస్ ఆర్ ద ఎంటైర్ పాసిబుల్ క్వశ్చన్స్ based on the equation. This chapter includes one more part that is called as what? Simple pendulum. So ఇక్కడ సింపుల్ పెండ్యులం గురించి మాట్లాడుకున్నప్పుడు కొద్దిగా గ్రావిటేషన్, యాక్సిలరేషన్ డ్యూ టు గ్రావిటేషన్ గురించి కూడా మాట్లాడుకోవాల్సి వస్తుంది. సో దిస్ ఈజ్ అబౌట్ ద పార్ట్ ఫస్ట్, నాట్ ఓన్లీ ఫస్ట్ పార్ట్, ఆల్మోస్ట్ ద కాన్సెప్ట్ ఆఫ్ వాట్? సింపుల్ హార్మోనిక్ మోషన్. ఇన్ ద నెక్స్ట్ వీడియో విల్ బి సీయింగ్ the concepts related to simple pendulum and acceleration due to gravity. So right, thank you for watching the video. Please subscribe to the channel for more videos. Thank you.